So again, you can think of it in brackets, that 4. That 4 is on the outside, so that you make sure that you see that that's your outside function, because sometimes you're going to be tempted to do the derivative of tan first, because that 4 is sneaky and in the inside. But if we take the time to rewrite, well, what does that tan to the 4 mean? It means that whole thing is to the power 4. Then our outside function is the power. So you do that first. The 4 comes out in front, subtract 1 from the exponent. Then what was inside of that? Tan of 2x. Still another chain rule. So the derivative of tan is secant squared, and the 2x would still be inside. Then you look at the function that was still inside, which is 2x, and the derivative of that would be 2. Have you all had a chance to look at the next one as well? So here we've got a function h of x. We need to take the derivative, and then we need to rearrange it so that it looks like this form. So the first thing we can do is our quotient rule. Keep the bottom one the same. Derivative of the top one minus, keep the top one the same. Derivative of the bottom one over the whole thing on the bottom squared. Now what I've done here, or what you can see here, is that there was an x minus 1 in this first term and an x minus 1 in this second term. Technically that means you can factor it out, and once it's factored out, you'll be able to cancel it with one of the x minus 1s on the bottom. So there's two ways of doing this. You can actually factor it out and then cancel it, or in this case, we notice there's an x minus 1 in both of them, and I just simplified that right away with the x minus 1 to the 4 on the bottom. As a result, we get x minus 1 minus 2x minus 2, expand the top and simplify, and we end up with 3 minus x over x minus 1 cubed. And that is in the form that was listed above. So again, here's a show that question. So what we do is we just start with what we know, and then we want to, in the end, make it look like this. Some things prior to even starting, I'm like, I look at this, I go, okay, I know how to do that. I'm going to have a chain rule, and I'm going to have some derivatives of sine to do. In the end, I see a cos 2x, so I'm thinking I'm probably going to have to use an identity somewhere. So that's sort of my preparation in this question. Again, I might take the time until I get really good at these to rewrite that sine cubed x as sine x all cubed, so that I can see, oh, that's a chain rule. So now when I go to my derivative, the 3 comes out in front, making that a 6. The sine x stays the same. Take away 1 from the exponent. Then the derivative of the inside is cos x, minus the derivative of 3 sine x. Well, the derivative of sine x is cos x. So there's our first step. We take our derivative as normal. As far as the second step goes, what I'm going to do next is I'm going to look at what I have and look at what I want. And is anything in what I want close to what I have there? Because what I have in what I want at the end is I want a minus 3 cos x times by a cos 2x. So looking at my function, I can say to myself, well, both of these terms, there's my first term, there's my second term, they both have a cos x, they both have a 3, so why don't I start by factoring out a minus 3 cos x and see what's left inside? Can you see that if you took out a minus 3 cos x out of the first term, you'd be left with minus 2 to get positive 6 and sine squared, and a plus 1. So what prompted me to do this wasn't anything as a natural algebraic step from the previous one. I mean, you could factor it, but probably you wouldn't take out a minus 3 if you did that. But it prompted me to do that because I saw right here that we had minus 3 cos x in what we wanted as our final show that answer. Now the only thing I need to do is change this, 1 minus 2 sine squared x. You look at your identities and you go, oh, that matches up perfectly. And so we're done. So I would say the hardest step in this one is going from here to here, and that's where you're thinking about what you want to show and saying, is there anything that I can do at this point that helps me get there? Okay, for 5 and 6 on the next page, again, I'll give you guys a head start. So again, we're going to start with doing the derivative and keep the first one the same, derivative of the second one, and the second one has a chain rule. Take the exponent down, but the inside, the derivative of minus x is minus 1. Plus, now keep the second one the same, derivative of the first one. So there's our first step, just taking a derivative. Now, looking at what we want, we're going to want to have a square root on the bottom of our fraction. So the next thing I'm going to do is, and I look at the top of my fraction, I notice there are no square roots or listed at all. So what I'm going to do is I'm going to take my equation, I'm going to write x to the 1/2 back as a square root. I'm going to simplify this is going to be times by negative 2, 3 minus x, plus 3 minus x squared over, because that's a half, the 2 would be on the bottom, and x to the negative 1/2 would be 2 square root of x on the bottom. So the nice thing now is in my second term, I have that 2 root x on the bottom. But in my first term, I can think of this as all being over 1. How do I add fractions? Need a common denominator. So if I want to get a single fraction in the end with a 2 root x on the bottom, it makes sense to get a common denominator in our first term, so I have that 2 root x on both of them. Can you see that now I would have a common denominator, and I could just add the tops and add the bottom, or keep the bottom the same. So there's my 2 root x as my common denominator. What's going to happen when I get 2 root x times a root x? That's just going to be 2x. So I'm going to have 2x times a negative 2, which would be negative 4x, 3 minus x, plus 3 minus x squared. Now you have two different ways to go from this point. Method one would be to expand everything on the top, combine your like terms, and then factor. If you expanded everything on top and combined the like terms and factored, you should get this. I'm going to say that that's going to be a longer way. There is a shorter way. You see that we want a 3 minus x up there. And if you look at both of your terms on the top, do you see that there's a 3 minus x in both of them? So the faster way is to factor right away. What happens if I take a 3 minus x out of both of them? What am I going to be left with in my first term? Just a minus 4x. What am I going to be left with in the second one? I still have another 3 minus x. Then it's just a matter of combining things. And minus 4x minus x will give me 3 minus 5x over 2 root x. So we were able to show that it was equal to what? Now, hence or otherwise, these are IB words. These are IB command words for your exam. Hence means that you have to use the result from before to get your answer. Otherwise means you could use something else. But the fact that they're telling you hence or otherwise, they're kind of saying it's a good idea to use the result you just got because it's probably going to be helpful. So, hence or otherwise, find all the x coordinates of all the points on here where the tangent is horizontal. What does that mean? Okay, we've got some sort of function like this. We're looking for wherever we can draw tangent lines that are horizontal. What does the derivative tell us? Because we just found the derivative. So if we're going to use the hence part, we're going to use the derivative. What does the derivative tell us about slopes of tangents? Well, that's what the derivative is. The derivative is an equation for all the slopes of all the tangents. So if we want the tangents to be horizontal, what are the slopes of these lines? 0. In other words, we're looking for where is our derivative equal to 0. Now, the nice thing, if we look at our equation and we say, well, let's make it equal to 0, and if we use what we've already have, when is a fraction equal to 0? When the numerator is 0. And since it's already factored in the numerator, can you see that x would have to be 3, because that would make the numerator 0, or x would have to equal 3/5, because then the second term would equal 0. And so that's where the hence part comes. Because we've already factored it, it makes it easier. The otherwise means you could have done it a different way. If this was a calculator question, you might have been able to use your calculator to find those points. But in this case, it's easiest to go directly from the hence. Okay, I'm going to leave you example 6 to do on your own, because I want to go forward and work on Newton's quotient for a little bit. So here's your handout. Oh, this is a review sheet. Here's the handout of review of Newton's quotient.